My name is Nurzulaika Batrisha binti Sasti. My matrix number 216498. So the first question, function assigned is fx is equal to 1 over 3 x to the power of 3 plus 1 over 2 x to the power of 2 minus 6x plus 8. So the first question is the critical number of fx. This question, we have to find the first derivative for the function fx is equal to d over dx multiplied with 1 over 3 x to the power of 3 plus 1 over 2 x to the power of 2 minus 6x plus 8. So the first derivative of this function is f prime x is equal to x to the power of 2 plus x minus 6. For the critical number, it occurs when the first derivative is equals to 0. Since this derivative is defined for all value of x, so the function is x to the power of 2 plus x minus 6 is equal to 0. Then we have to factorize it. X plus 3 multiply with x minus 2 is equal to 0. So the first critical number is x plus 3 equals to 0. So we have x equals to negative 3. Then x minus 2 is equal to 0. We have x equals to 2. So the critical number is x is equal to negative 3 and x is equal to 2. Question B, the point of which function fx has a relative extremum. This question, find the second derivative, which is f double prime x is equal to d over dx multiplied with x to the power of 2 plus x minus 6. So the function of double prime of x is 2x plus 1. Then we have to test that x is equal to negative 3. Substitute x into the second derivative using function of the second derivative. F double prime negative 3 equals to 2 multiply negative 3 plus 1, we have negative 5. Since it's negative 5, the graph concave down and relative maximum. To find the y value, we have to substitute negative 3 into the original function, which is 1 over 3 multiply negative 3 to the power of 3 plus 1 over 2 multiply negative 3 to the power of 2 minus 6 multiply with negative 3 plus 8. We have 21.5. Right, we test x equals to 2. Substitute x into second derivative, which is 2 multiply 2 plus 1 is equal to 4. So the graph is positive, concave up, relative minimum. To find the y value, substitute 2 into the original function, and we have 1 over 3 multiply 2 to the power of 3 plus 1 over 2 multiply with 2 to the power of 2 minus 6 multiply with 2 plus 8. We have the answer 0.67. Then we have relative maximum point negative 3, 21.5, relative minimum point 2, 0.67.
For question 1c, we find the interval where the function is increasing or decreasing. The given function is f of x equals to 1 over 3x cubed plus 1 over 2x squared minus 6x plus 8. From question 1a, the first derivative equals to f prime of x equal to x squared plus x minus 6. To find the critical numbers, we set the first derivative equals to 0. So, x squared plus x minus 6 equals to 0. And then we factorize the equation. X plus 3 times x minus 2 equals to 0. Therefore, x equal to negative 3 or x equals to 2. Then, divide the number line into 3 intervals. The first one is negative infinity, negative 3. Then the second one is negative 3, 2, and the last one is 2, infinity. These are the only possible intervals where the sign of f prime x can change. Next, choose a test value in each interval and find the sign of f prime x. For the interval 1, negative infinity to negative 3. Choose x equals to negative 4. F prime of negative 4 equals to 6, which is positive. For interval 2, negative 3 to 2. Choose x equal to 0. F prime of 0 equals to negative 6, which is negative. For interval 3, 2 to infinity, choose x equals to 3. F prime of 3 equals to 6, which is positive. Therefore, the function is increasing on negative infinity to negative 3, union to infinity. Then, the function is decreasing on negative 3 to 2. For question 1b, we sketch the graph of the function using GeoGebra. So the given function is f of x equals to 1 over 3x cubed plus 1 over 2x squared minus 6x plus 8. From the previous question, the important points are identified. The relative maximum occurs at x equal to negative 3, if y value equals to 43 over 2. So the relative maximum point is negative 3, 43 over 2. Then the relative minimum occur at x equal to 2, with y value equals to 2 over 3. So the relative minimum point is 2, 2 over 3. Lastly, the x-intercept is obtained when x equal to 0. We substitute x equal to 0 into the function f of the 0 equals to 8. So the y-intercept is 0, 8. From the question 1, part C, the function is increasing on negative infinity to negative 3 and 2 to infinity. The function is decreasing on negative 3 to 2. Since the highest power of x is x cubed and the coefficient is positive, the graph is a cubic curve that goes downward on the left and upwards on the right. Using GeoGebra, the graph is plotted with the relative maximum, relative minimum, and y-intercept clearly shown. Please complete the sketch of the graph for the question 1D.
Assalamualaikum and hello everyone. My name is Anissa Lobajamat Sadikin and my matric number is 214959. As for question number 2, the question is two parallel sides of rectangle are being lengthened at the rate of 2 inch per second, while the other two sides are shortened in such a way that the figure remains a rectangle with a constant area A equals to 50 inch square. What is the rate of change of the parameter P when the length of an increasing side is 5 inch for A? And B, what is the rate of change of the parameter P when the length of an increasing side is 10 inch? And C, what are the dimensions when the parameter ceases to decrease? Given from the questions, area of the rectangle A is equals to xy. Area is constant, so A equals to xy equals to 50 inch square. Next, we will differentiate both sides with dxy over dt equals to d50 over dt. So the right sides will become d50 over dt equals to 0 because 50 is a constant. As for the left side, xy is a product of two time varying quantities xt and yt. So I use the product rule. And it will become dxy over dt equals to x dy over dt plus y dx over dt. So I'll get the equation x dy over dt plus y dx over dt equals to 0. And then we will rearrange the equation that we have got, which is dy over dt is equals to minus y over x dx over dt. From the questions, we already know that dx over dt is equals to 2 inch. So then we will substitute dx over dt into the dy over dt. So dy over dt, we will get negative y over x times 2. Next, we already know the y value because in the questions it's already stated that xy is equals to 50, and then from here y is equals to 50 over x, and then we substitute the y value into the dy over dt, and the final answer we will get dy over dt equals to negative 100 over x squared. Okay, so moving on to the perimeter of the triangle, which is p equals to dx plus dy, and then we'll differentiate both sides, which is dp over dt equals to 2 times dx over dt plus 2 times dy over dt. And then we'll factorize this equation. and we will get 2 times dx over dt plus 2 dy over dt. Okay, from above calculation, we already got the value for dx over dt plus and dy over dt. And then just substitute the value that we have got into these equations. And then we will get dp over dt equals to 2 times 2 minus 100 over x squared. And then just solve this equation. And the value for this parameter differentiation is 4 minus 200 over x squared. For question A, the question is asking us to find the rate of change of the parameter p when the length of an increasing side is 5 inch. So from the calculation that we have done above, we can just use the formula, which is dp over dt equals to 4 minus 200 of x squared. So x is equals to 2, so x should be substituted into the equation. Then we will get 4 minus 200 over 5 squared, and then we just solve these equations, and the final answer, we will get the parameter is decreasing at 5 inches per second. So dp over dt equals to negative 4 inch per second. As for question B, the question is asking us to find the rate of change of the parameter p when the length of an increasing side is 10 inch. So the solution is similar to A, which is we are going to use the equation dp over dt equals to 4 minus 200 over x squared, and x is given, which is 10, and then we're going to substitute the x value into the equation. And we are going just solve this using calculator, and the final answer we will get is the parameter at x equals to 10, the parameter is increasing at 2 inches per second. So dp over dt is 2 inch per second. Okay, last but not least, for question C, what are the dimensions when the parameter ceases to decrease? Ceases to decrease here means that the parameter have stopped decreasing. So dp over dt is equals to 0. And the formula of dp over dt is, which is 4 minus 200 over x squared, is also equals to 0. From this equation, to move this fraction to the other side, and then it becomes 4 equals to 200 over x squared, and then multiply both sides by x squared, which we will get 4 x squared equals to 200, and then divide the answer with 4, and then we will get x squared equals to 50, and the final answer, x is equals to 5 third 2. So to find y, just like the question given, xy is equals to 50, so y is equals to 50. So just substitute the value of x into this equation, and then we will get the same value for y, which is 5 third 2. So the dimensions for x and y is 5 third 2 inch, which means that the parameter has stopped decreasing exactly when the rectangle becomes a square.
Next, question 3. The question is, the total cost of producing X radio sets per day is Rm1 over 4 x squared plus 35x plus 25. And the price per set at which they may be sold is Rm50 minus 1 over 2x. So, for A, what should be the daily output to obtain a maximum total profit? So, before we find the profit, we need to identify our known variables. The first one is total cost, Tx equals to 1 over 4x squared plus 35x plus 25. The next one is price per set, Sx equals to 50 minus 1 over 2x, and total revenue, Rx, which is simply the price multiplied by the quantity x, which leads to 50x minus 1 over 2x squared. To find the maximum profit, we need to define the profit function first, Px, by subtracting total cost from the total revenue. After substituting our equation, we simply arrive at Px equals to negative 3 over 4x squared plus 15x minus 25. To find the maximum profit, we take the first derivative, P prime x, and set it to 0. By solving this, it will give us x equals to 10. And this will tell us that producing 10 radio sets per day will yield the maximum profit. Now, let's move on to the part B of the question, which is show that the cost of producing a set is relative minimum at that output. So, we want to show that the cost of producing a single set, known as the average cost, is at a relative minimum when we produce those same 10 sets. So first, we define the average cost function, which is Ax, by dividing our total cost, Tx, by the number of units x. So this will simplify our function to 1 over 4x plus 35 over x. So to find the stationary points for this course, we have to differentiate ax to get a prime x. So as shown on the slide, a prime x is 1 over 4 minus 25 minus x squared. So when we substitute 10 into the derivative, the result will be exactly 0. And this will confirm that x equal to 10 is indeed a critical point for the average cost. Finally, we must prove that this critical point is a relative minimum rather than a maximum. We do this by doing the second derivative test. We will differentiate our average cost once more to find a prime prime x, which will give us 50 over x cubed. So when we substitute x equals to 10 into the second derivative, we will get a value of 0.05. So if the second derivative at a critical point is greater than 0, it means that the function is concave up, meaning the point is a relative minimum. Therefore, we have successfully shown that producing 10 units not only maximizes the profit, but also achieves the minimum average cost per set.
Next, question number 4. Evaluate each of the limits using L'Hopital rules. For the first question, we have the limit as x approaches 0 of sine 3x over 4x. For the step 1, we have to check the form by substitute x equal to 0 to both numerator, which is sine 3x, and denominator 4x. Then we get the limits to become 0 over 0, which is we can use the L'Hopital rules. For the second step is we have to differentiate the numerator and denominator separately. D over dx sine 3x, we get 3 cos 3x, and d over dx 4x, we get the answer as 4. For the last step, we have to evaluate the new limits and substitute dx equal to 0 to the new limit. As cos 0 becomes 1, we just directly multiply the 3 and 1, and the final limit we got is 3 over 4. Next question is, we have the limit as n approaches infinity of the limits 3 exponent to the power of 2n over 4n squared. For the first step, we have to check the form by substitute n equals to infinity to the both numerator, which is 3 exponent to the power of 2n, and the denominator, which is the 4n squared. Then after that, we get the limit to become infinity over infinity, which is we can apply the L'Hopital rules. For the second step is we have to differentiate the numerator and the denominator separately. So the d over dn of the 3 exponent power of 2n, we get the 6 exponent to the power of 2n, and for the d over dn for n squared, we get the answer as 8n. And as we can see, after differentiate, we still get the answer to become infinity over infinity form. So we have to apply this rule for the second time. So d over dn, 6 exponent to the power 2n will become 12 exponent to the power 2n. And for the next one, d over dn 8n will become just 8. After that, we evaluate the new limit and substitute the n equals to infinity to the new limits. So 12 exponent power of 2n, which is we subs the n to become infinity over 8. So we get the final answer as the infinity over 8, and as the numerator is infinity, the whole thing goes to infinity. So the final answer of this question is infinity. For the third question, we have the limit as x approaches 0 from the right of x squared ln x. When x approaches 0 from the positive side, x squared becomes 0 and the ln x become negative infinity, giving the indeterminate form 0 multiplied by infinity. So to apply the L'Hopital rule, we have to rewrite the limit as a fraction, and the limits become ln x over x to the power of negative 2. Then we just substitute the x equals to 0 to both numerator and denominator, and we get the form of infinity over infinity. After that, we differentiate the numerator and the denominator separately. D over dx ln x, we get the answer as 1 over x, and the d over dx for x to the power of negative 2, we get the answer to become negative 2 power of the negative 3. After that, we have to evaluate the new limit and simplify it because our limit is too complicated. So we have to simplify it to become limit x approaches 0 from the right side, 1 over x multiplied by x cubed over negative 2. And the answer we get from that is limit x approaches 0 from the right side, x squared over negative 2. After that, we just substitute the x equals to 0 into the new limits, and the final answer we get is 0. So for the last question, we have the limit n approaches infinity and exponent to the power 2n. Firstly, we have to substitute n equals to infinity. As n approaches infinity, both n and exponent to the power of 2n increase without resistance and forming infinity multiplied by infinity form, not as infinity over infinity form. So since this is not an indeterminate form, the L'Hopital rule is not required. So therefore, the limit answer is just simply infinity.